Hello all. I think in a previous sessions you have studied about a one dimensional array. So, array is a collection of similar data item where having a similar data type. So, that is what we call it as a array. So, in a array, in previous sessions you have studied about a one dimensional arrays. Now, let us move on to the next concept in an array, that is two dimensional array. Now, let us understand what is that two dimensional array. So, when it comes to the one dimensional array where it contains a single subscript. But now when we come across the two dimensional array, we can say it is two dimensional array will be represented in the form of a table. Like when it comes to across the table, when you are viewing a table, see for example, if you think this is a table, when I wants to view the table, we are viewing the table and accessing the elements of the table in the form of rows and columns. Rows and columns. So, whenever we want to access a two dimensional array, we require two subscripts. So, when we can conclude that is two dimensional array is specified by using two subscripts. And another thing is, whenever we got a two subscripts, in that first subscript will always represent the row value, place of the row. And next, the second subscript is always refers to the column. So, when you consider the two dimensional array, it is also a collection of a similar data items, but it is in the form of a rows and columns. That is what we call it as a two dimensional arrays. Now, when you look at this picture, you can easily understand that there are two dimensions are present. The two dimensions are, one is the first dimension. The first dimension is always refers to the row, and the second dimension is always referring to the columns. So, when you look at here, the row dimension and column dimension. So, because of that reason, we are going to use two subscripts for the two dimensional array. To represent two dimensional array, we are going to have a two subscripts. Now, when we look at the concept of this two dimensional array, the next concept we come across in a C language is to declare the array in a program. So, you know that one dimensional array, how we are going to declare it. So, while declaring the array, that is one dimensional array, we used to have a one subscript. But when you come across in a two dimensional array, the two dimensional array consists of two subscripts. First subscript is representing the row, second subscript is representing the column. So, whenever we are going to declare the two dimensional array, the declaration syntax is contains data type. Which type of data we try to store it in a two dimensional array, that is data type, and along with this name of the array, we have to specify the name for the array. Next, we have to specify number of rows, that is the row size, and next number of columns, the column size. This is how we are going to declare the two dimensional array. For example, if an array is of integer data type, then int is going to specify the data type and name of the array. For example, numbers are representing just the name of the array. Next comes here is number of rows are 5, number of columns is 3. So, this has been the syntax, and we have obviously we require the semicolon at the end of the statement. So, this is how we are going to declare the data, this is how we are going to declare the two-dimensional array. When you declare the two-dimensional array, like we are going to have a 5 rows and 3 columns. When we are having 5 rows and 3 columns, let us look at how many data elements are present inside that table. So, when you consider the data elements present in the table, it always will be m cross n. M is representing the rows and n is representing the columns. In a table, if there is a 5 rows and 3 columns, 5 into 3, 5 into 3, 5 into 3 is equal to 15. So, 15 data elements will be stored in the memory location. So, that is what here represented. In a two-dimensional array, there is m cross n array data elements will be present. Always we are going to access the array elements, that is two-dimensional array elements, by using the subscript of that array element. So, that is the array element is represented by the two subscripts I and j, where I is representing a subscript of the row element, subscript, j is representing the subscript of the column. So, there are m cross n data elements are going to be stored in a table, that is in a memory, in a two-dimensional array. Now, let us look at the example of a two-dimensional array. Example, let us consider the dimension, that is int marks, data type is int, marks is the name of the array and the dimension is 3 cross 5. So, this indicates the size of the row is 3 and the size of the column is 5. Now, in a memory, how this is going to be represented and how the subscript is being assigned for this particular rows and columns. Now, let us look at this example. Let us look at this example with the rows and columns. Now, there will be, as the size is represented here as a 3 rows, so the memory allocation will be done for only for the 3 rows. 3 rows, and the size of the column is represented as a 5. So, 5 rows will be present. Rows. And the name of the array is marks. So, whenever there is a marks is a group of elements where the elements are m3 cross 5 elements are present in this table. Then it is containing its own subscript. Those elements can be accessed with the subscripts. Now, let us look at the subscripts. Now, it is, when you consider this part, this is the row 0. Always while indexing, the subscript is going to start with a 0 subscript. So, always the array start with a 0 indexing. So, according to that, it contains row 0, row 1, row 2. Next, columns, 5 columns. So, column 0, column 1, column 2, column 3, column 4. Now, this is what the number of columns and number of rows. To access the elements of this particular table, we need to access the table, or we are going to access the elements present in the table by knowing their subscripts. So, the subscripts here is the first column, first row subscript, that is the marks 0 of 0. Marks 0, 0 representing the element present in the first row, first column. Next, marks with the subscript 0, 1 representing marks 0th row, first column. Next, marks 0th row, second column. In the same manner, the marks 0th row, third column. In the same way, the marks 0th row, fourth column. In the same manner, it continues till the end for the same manner, but the row is going to be changed here. Row marks row 1, column 0. Next is marks row 1, column 1. Next, marks row 1, column 2. Next, element marks row 1, column 3. Next, marks row 1, column 4. The same will be continued for the next row also. That row is second row, that is marks 2, 0, that is indicating second row, 0th column. If you want to access the element of the third row, the third row will be subscripted by using 2, because here the subscript or indexing is going to start with 0. When it starts with a 0 value, 0 is the first column, 1 is the second column, sorry, 1 is the first, 1 is the second column. In the same manner, 0 is the first, row 0 is the first row, row 1 is the second row, row 2 is the third row. In the same manner, column 0 is the first column, column 1 is the second column, column 2 is the third column, column 3 is the fourth column, and column 4 is the fifth column. So why it is, it contains 5 columns, but indexing starts with a 0, so it is last one is 4, the subscript is 4. Okay. In the same manner, here also the second row, if you want to access the second, that is the third row elements, we need to access with these subscripts, that is marks is the name of the array, marks 2 of 1, that is second row, that is the third row, which is indicating index is 2, and second column indicating 1. So marks of 2, 1, marks 2, 2, marks 2, 3, marks 2, 4. So this is how we are going to access the two-dimensional array data elements by indexing. So this is what the thing, where if you consider this is the example of data declaration and declaration of a two-dimensional array, which is containing int marks, size of the marks is the name of the array, size of the row and size of the column, and this is how the data elements will be represented, and we are going to access the data elements with the name of with the subscript, with the name of the array and along with the subscript of the elements. Now let us move on to the memory representation. See, what happens here is, whenever we are storing the data elements in a memory, always the memory is going to keep the elements in a sequential manner. See, whenever it is representing, it is like a memory, it is just like a Almirah. So what happens here is, the memory is going to be saving the data in a sequential manner, one after the another. So whenever the data elements are storing in a sequential manner, it is just a conflict like how to store the table in a memory. So that's the main question arises, how to store these data table in a sequential manner. So during the memory representation, we are going to come across two ways we are going to save the data elements in a table data elements in a sequential memory. That is, the first one we are going to two ways we are going to save the data elements. Two ways to save the data elements here is, one is the row major order. As I said, the memory will be in a sequential manner. The memory stores the data in a sequential manner. Now the next question is how to save this table, that is two-dimensional array, in a memory sequentially. There are two ways to store the data in a memory. That is, the first one is row major order. In this case, the content of the table will be stored in a row wise. That is, first the contents of all the rows are going to be stored sequentially, and next second row data elements are going to be saved sequentially. Next, the third row elements are going to be saved sequentially in a memory. So, like example, now let us, in this table itself, it is a two-dimensional table where it is a row major and the column major. When you consider a row major, first the row wise elements are going to be saved. That is, row, always the first row elements are going to be saved sequentially. The first row elements, the first row is represented with the index 0. So, now let us look at here. It is going to be start saving 0, 0, that is 0th row, 0 column, 0th row first column, 0th row second column, 0th row third column, 0th row fourth column. In the same manner, it continues next for the first row, that is row number 1 with the subscript 1. That is, it is sequentially, it keep on storing the elements in a row wise. At the end, last what it will get, we are going to get second row. At the last we are going to have, in the same manner, it is going to store with the 2, 3, 2, 4. This will be the last element in a row. Row wise it keep on storing. That is what we call it as a row major order. Next, how we can represent in a column major order. In a column major order, the data starts from the column number 1 and sequentially it starts storing the data in a memory in a column wise manner. That is, first it will store the column, first column, next the second column data elements, next the third column data elements, next it keep on continues till the end. So, now in this way, where we can, this is what we call it as a column major order. In a column major order, first the first column is the 0th column, that is 0 row 0 column, first row 0 column, second row 0 column. This is one part. Next it jumps to the next row, next column is, that is 0th row first column, first row first column, next second row first column. So, it keep on continues and at the end it comes to the last column. That last column is the 4. The subscript of the last column is here in this example is 4. That 4 is 0, 0, 4, 1, 4, next 2, 4. 2, 4. This is what here 2, 4. So, this is how we can store the table, that is a two-dimensional array, in a memory, that is in a sequential format. So, now let us look at how the addressing is going to take place in a row or major order and the column major order. Now, let us look at how the addressing of a memory location takes place in a row major order and column major order with representing in a formula. Now, let us look at this column major order. Address here is address A is indicating a address. So, address of I subscript and J subscript. Address of I and J subscript is equal to base address. Base address is also called as starting address. Base address plus W. W is indicating the number of words. W. M. M is indicating the number of columns. W is indicating the words that should be stored in memory permanently. That is what the W. W is number of words. Next, M. M is the columns. Next, J minus 1 plus I minus 1 altogether. This is the first formula. This is what this formula which is used to represent the address of a column majors, the starting address. See here what happened, ith row, jth column. Address of ith row, jth column can be calculated in a column major order by using this formula. That is what, this is what the formula, this is the to access array elements and stored in address in column major order. So whenever you want to access the data elements, you can access the data elements by using the subscripts, and also the address of a particular memory location can also be calculated in a column major order by using this formula. In this formula, we can say that W will be indicating, W is a number of words stored per memory location. That is what word. The next one is M is number of columns. Next is N is indicating N will be indicated as number of rows. Where I and J is indicates the subscripts. So now this is what address. Now let us look at the formula of row address order. In this formula, as we seen here, this is the calculation of address of a data elements where it is stored with respect to the column major order. Now this formula, that is A of ij are representing the subscripts, is equal to base address. Always the base address is indicating the starting address of a memory location plus W. As you know that W is the number of words stored per memory location. That depends upon the data type. Which type of data type it is, whether the array is an integer data type, float data type, or other, if it is a strings. So next here W, next N is the number of rows and I minus 1 plus J minus 1. This particular formula is going to be referred for the memory location when the data elements are arranged in the form of row major order. Now let us look at initialization of two-dimensional array. What is this initialization? Like we have declared the array, and after declaration we have got reserved a table or reserve a sequence of memory location. Now the next part is we are going to store the elements in a memory location. That is what the initialization of a elements. So while performing initialization, there is a two ways we are going to initialize. The first method here is by using assignment operator. So by using assignment operator, we are going to assign the values to the particular rows and columns. Example. Now let us look at this example. With the example we are going to understand how we can assign the values to the two-dimensional arrays or initialize the values to two-dimensional arrays. Now let us look at here int data type. You know that how we are going to declare the declaring the two-dimensional array. While syntax here is first we are going to come across, that is the integer data type and the name of the array and size of the rows and size of the columns. Now with this example we can see here the data type is integer, marks is indicating the name of the array, next size of the row is 2 and size of the column is 3. See, if you are having 2 rows and 3 columns, the total number of data elements we can store in a table here is 2 into 3, that is m cross n, m into n, that is 2 into 3. So total 6 elements we can assign to this memory location. So by using a assignment operator in a declaration part itself, we try to assign the values to the memory location or to the two-dimensional array. So here is the example with a curly brace open, and then we are going to store the 6 elements, close the curly brace and semicolon, it is the end of the statement. This is the one way of assigning the values to the two-dimensional array. The next is how we can initialize it in a row by row manner. We have to indicate the first row and next the second row. This row by row manner to initialize the values is in this format, that is first in the same manner int data type, next array, name of the array, next is size of the row, size of the column, next how many rows are there, there are 2 rows are there, the separating the 2 rows values with a comma and place it inside the curly brace, that is the first row is present inside the curly brace, first curly brace, and the second row is inside the second curly brace and end with the end statement. Now we can also assign initialize the entire table or entire two-dimensional array with a 0 by indicating the 0 value, that is int marks 2 3 and is equal to 0. So this is the one way of initializing the two-dimensional array datas. And the second way how we can initialize the two-dimensional array in a second manner is by using a scanf statement. The scanf statement is placed inside the 2 for loops. We can easily assign the values or enter the elements of this particular two-dimensional data. That is, so initializing the two-dimensional array in a second way is by considering the scanf statement. When we are having a scanf statement, the scanf statement must be inside the 2 for loop, because first for loop, that is the outer loop, is representing a row or row order, and the second column is second for loop is representing the column. So in this way, like if you are having a m rows and n columns, m rows and n columns, first is m is representing the row and n is representing the number of columns. So inside the for loop, for I is equal to 0, always you should start with the 0 value, because the index is 0. First row index is 0, and I is less than m, it must be less than m. Next is I plus plus. This outer loop is indicating for the row. Next, inside this another for loop which indicates the column values. Column subscript j is equal to 0. Always the column is also subscript will start with index 0. J is less than n number of columns, j plus plus. Now next we are going to enter the elements or initialize the elements by using a scanf statement, that is scan scanf %d ampersand of comma ampersand of marks of I j So this is the another way of initializing the data elements into the table. Now let us look at the various operations that is performed on the matrix. Now let us look at the operations on two-dimensional arrays. So two-dimensional arrays are just viewing like a matrix. So the whatever the operations we are going to perform on the matrix is exact operations can also be done on the two-dimensional arrays, because two-dimensional array itself is a matrix. So in a matrix we are going to perform mathematical operations on matrix, like we are going to perform the transpose of a matrix, difference of the matrix, sum of the matrix, matrix multiplications. So those concepts or those operations and all can be performed on the two-dimensional array. So now if we consider the m cross n elements, that is m rows and n columns. So matrix or a two-dimensional array is going to view in the form of a grid. When it is viewing in the form of a grid, it contains m number of rows and n number of columns. Let us consider a matrix A of I j, where I and j are the subscripts. A of I j is containing the size is m cross n elements. The size of a matrix A is m cross n. And we can apply the transpose operation by just converting the rows as a columns and column as a row. That is by converting A of ij to n cross m matrix. So m cross n is the original matrix, whereas n cross m matrix is the transpose of the matrix. So we are going to have B of ij is equal to A of ij, where B of ij is n cross m matrix, whereas A of ij is the B of ij is equal to A of ij, where B of ij is the transpose of a matrix A of ij. Whenever you apply the transpose operation on A of ij, that is converting rows into columns and columns into rows, during that time we are going to obtain transpose of the matrix. This is the first operation which we are going to apply on the two-dimensional array. The next one is addition of a matrix. When we consider the addition of a two matrix, if we require a two matrices are required. The two matrices are required with the same number of rows and same number of columns. That is, the first matrix rows must match with the second matrix row and first matrix column must match with the second matrix column. In that time we can perform the addition of two matrices. So here whenever you having two matrices, let us consider M cross N is A of Ij is the first matrix, and once again B is the another matrix, B of Ij is the matrix. It is also contains M cross N elements. Then we are going to obtain, that is C of Ij is the summation of both the A of Ij plus B of Ij. That is a one thing. In the same manner, the difference is subtraction. If we want to perform the subtraction operation or a difference operation between the two matrices, in the same manner, we should require the first matrix row must match with the second matrix row, first matrix column must match with the second matrix column, and then we can perform C of Ij. C of Ij is equal to A of Ij minus B of Ij. This gives you the some difference between the two matrix elements. The next operation here is product, that is multiplication. Whenever we are performing the matrix multiplication, we have to follow certain rules to obtain the matrix result, that is a product. So here in this case what happens, if a matrix A is equal to M cross N and matrix B is equal to P cross Q, what happens is the condition here applies here is the number of columns of the first matrix must match with the number of rows of the second matrix. If both are same, that is the column of the first matrix, row of the second matrix, that is the size of the column of the first matrix and size of the row of the second matrix, if it is same, then we are going to obtain the product in the size of M cross Q is the size which we are going to obtain. And to calculate the matrix operation, the formula which we are going to follow here is Cij is equal to summation of A of Ik comma into B of Kj for k is equal to 1 to k is less than n. K is less than n. This is the formula to obtain the entire, that is the matrix C of Ij, that is a product of two matrix A and B. So these are all the operations which we can perform on the two-dimensional array. Now let us look at how we are going to pass the parameters, that is the 2D parameters to the function. That is what here, passing two-dimensional array to function. Now let us look at passing the parameters to the function. While passing parameter to the function, the parameters are two-dimensional arrays. So whenever we are passing two-dimensional arrays to the function, we are going to pass the elements of the array in three ways. That is, the first one is we can pass the individual elements of a two-dimensional array to the function. That is, by passing individual elements is just similar to that of individual elements passing in a single dimensional array. The next second concept here is passing the row values. Whenever we are passing the parameters in the row format, that is from a two-dimensional array we are passing the row value to the function. It is just passing like a single dimensional array data elements. The next, passing the entire two-dimensional array, that is the entire matrix data are going to be passed to the function. So in this section we are also look at the, now let us look at how the row elements of an two-dimensional array is going to be passed to the function. This is the example. This example shows that how we are going to pass the two-dimensional array only the row values. That is, here is the main function, main int, there is a array element with 2 rows, 3 columns, and there is a initialization is being taken place. Row wise the elements are present. This is the first row elements, next the second row elements, it's a initializing the arrays, two-dimensional array. Next we are trying to call the function. This function, the function name is func is the function name, and passing the array of one row. That is the first row whenever you are passing, we are trying to pass with the indexing a array 1. This is going to pass the, here the function func is a function, passing the parameters to the function is arr1. This 1 is indicating the first row, that is the value of the row number. See, indexing is going to take place with 0. There are 2 rows are there, 0th row and first row. So there is a row value, that is array of 1, that is the row index is given, that is the first row is going to be transferred. That is first means 1 here it is indicating, that is the second row is going to be transferred as passing. Now the function here is void func is the name of the function, parameter or argument which is received, here is array elements are being received. It is indicating a single dimension. So it is, we are just passing a one row elements to the function, and that then the function is going to take place int I. Now it's performing its operation. This operation what it is performing here is int I is being declared, that is a I is a variable. Now for loop for I is equal to 0, I is less than 5, I plus plus printf percentage d array of I is indicating the first row elements. Those first row elements will be multiplied by 10 and it is going to be printed. This is the function, where in this function we can easily understand in this function here is how we are going to pass the row elements. That is, the entire row is going to be passed to the function by indicating the row number, that is row index. That is what here array is the name of the array name, 1 is indicating the row value, that is the index, row index. This is how we are going to pass the row to the function. Concept of these three with an example. Now let us consider passing the entire array. Entire array is going to be passed and to the function and perform certain operation. Let us consider with an example. You want to perform addition of two matrices. Whenever we perform addition of two matrices, the two matrices are required. Because addition, obviously there is a two matrix, matrix A and matrix B, and next we are going to get the result matrix C. So now in a main function we try to access the two arrays, that is a two-dimensional array matrix A and matrix B, and then pass that matrix A and matrix B to the function to perform the addition operation. So now let us look at how we are going to pass the entire array. Now let us look at with this example. So this example, this program is to write a, this is the function to perform addition operation. So here as usual we start the program writing by writing with the #include stdio.h. It's a preprocessor directive, that is #include stdio.h. Now we are going to declare the functions before starting the main program. Let us declare this function, that is a void. There are two functions are there. First function is read matrix. Read matrix function int mat rows and columns, comma int, that is the size of the row and size of the column initialization. This is how we are going to declare the function before starting the main program. Next function we are using here is void sum underscore matrix sum mat, and obviously we require to pass a parameter, that is integer matrix we have to pass. There are two matrix we have to pass, that is A matrix and B matrix. So there is a argument which is present inside the argument. Here we are going to have two matrix, that is matrix 1, matrix 2, and size of the rows and column, that is int. These are the prototype declaration have been done before starting the main program. Now let us start with the main program. We are going to have void main program. Now we are going to have the int row value. ROW is a row, is indicating the size of the row. COL, size of the column. Next, two matrices are required. Matrix 1 of size 5, 5. So total there is a 5 into 5. We are going to reserve total 5 cross 5. 25 data elements can be stored in a matrix 1. In the same manner, int mat2, that is all the things are integer. mat2 is also 5 cross 5, because whenever we perform addition operation, both the matrix must have same number of rows and same number of columns. Next, the next step is printf. Enter the rows and number of rows and columns. Enter rows and columns, the number of rows and columns. It's just a printf statement. So by using scanf, we are going to use %d. %d is a specific modifier that is representing integer. %d. So now we are going to have a two datas we try to enter using keyboard, that is the size of the row and size of the column. So size of the row and size of the column for both the matrix is same. Percentage row, sorry, ampersand of row, comma, ampersand of column. Now, the first step here is, after having this, we try to read the elements of the first matrix, and next is we try to initialize or read the elements of the second matrix. So, we have written the function separately, that is a matrix. So, now the next step is we are going to call the read matrix function. See, here we are going to have a declare the two functions. We are passing the entire matrix must be passed. So, here what happens, two matrix are there, two functions are there, read matrix function and sum matrix function. So, read matrix function. So, read underscore matrix mat underscore matrix underscore matrix. So, we try to pass the mat1 here. So, that is what here mat1 comma, we are writing the name, this is the mat1 with a dimension, and we try to pass row value and column value, mat1 row comma column. This is how we are going to read the matrix of row 1 and column 1 in the same steps. These two steps are same. That is, once again you call the second matrix. You are going to call the read matrix. Once again you call the read matrix function, so that you can mat comma mat2. Here we are going to have the second matrix we have to read. We read the second matrix comma row comma column. Row column. And next, after this, after calling two matrix and passing the parameters mat1 row column, mat2 row column, the next function we try to call here is, the next function we are going to call here is, that is sum, sum mat, sum underscore mat. Whenever we are calling this function sum underscore mat, we try to pass two matrix, that is mat1 comma mat2 comma rows and columns, size of the row and size of the column, that is ROW, row comma COL, column. We are going to call this, and this is the end of the main function. Now we have completed the main function. This is, in this main function we try to call the sum mat function, and first we are going to call the read matrix function, and passing the parameter mat1, entire matrix we are going to pass and try to get that values, and entire matrix 2 we are going to pass and try to get the values. By using mat1 values and mat2 values, we call the sum function. We passes the entire matrix 1 and matrix 2 to the sum function and calculate the sum. Now, this is what the entire picture of main program. Now, let us look at these two functions, how it access the matrix elements and calculate the value. So, continuing the program, these are the two functions where the main function passes the parameter, entire two-dimensional array is being passed. So, now here this is the matrix, read matrix. This particular function is going to enter the values of the first matrix when we call for the read matrix 1. Next, the same function twice it is called to enter the second matrix value. The next one here is in the same manner. This is the sum of two matrix. This is the value like void sum matrix is a function. In this matrix, the argument which is present here mat1 and mat2 and int r, that is row size and column size. Now, the same value is going to be passed here. After passing the parameters, the summation is going to takes place, the sum of two matrix. that is all about the passing the entire two-dimensional array as a parameter. The last topic in the array in today's session here is multi-dimensional array. See, the multi-dimensional array, where we can see that in a two-dimensional array there are two indexes are there, whereas in a consider a n-dimensional array, there is a n indices are present. Now let us move on to the multi-dimensional array. So when it comes to the multi-dimensional array, it's also called as array of arrays. When you look at the one-dimensional array, it contains a one indices. Next, two-dimensional array, it contains two indices. Whereas in a multi-dimensional array, it contains n number of indices. The n number of indices like will be represented as a n-dimensional array, where it contains the matrices with the n dimensions m1, m2, m3, it goes on mn array collections. So, here we can have a n-dimensional array if it is represent it's a n dimension. So, we can have the elements, data elements which is present in n dimensional. So, we can m into n, m2, m2 into m3. So, m into n number of data elements are going to be m cross n number of elements are going to be present in the multi-dimensional array. Next, the elements in a multi-dimensional array is going to be represented by an index a of I1, I2, In, where I1 is less than or equal to M1, I2 is less than or equal to M2, In it goes on till In is less than or equal to Mn. So, this is all about a complete lecturing or complete. This is all about the complete picture of a multi-dimensional array, and along with this, in this complete video it has been described about a two-dimensional array and how to declare the two-dimensional array, initialize the two-dimensional array, next operations performed on the two-dimensional arrays, and how we are going to pass the array to the function. So, and at the end the multi-dimensional array. So, thank you.